setting the phone up for the lesson, which is the questions on alcohols that I set the other day. So for the benefit of my students, who are just the ones watching this at the moment, I am going to be putting this onto YouTube, available to everybody. So if you're not one of my students, the link to the questions that I'm answering is hopefully going to be in the description for the video. So if you wanted to access those questions, have a go at them, and then you can obviously watch the video back when I'm finished. Okay, so for my students, until we get our heads around how this is going to work, like I said in the description on Google Classroom, you can't get, I can't record the Google Meets at the moment because college hasn't authorised that. I can't do it. So what I'm going to have to do is do them on this way, so through YouTube, and then you can watch them the same way as before. The only difference, I suppose, is I can't see who's online. So I can see there's 8 people on at the moment. Potentially though, out of the 2 year 12 classes I've got, there's 28 students altogether. So there's 20 people not tuned in just yet. So because this can go onto YouTube, those 20 people can watch this. Whereas if I did it on Google Meet, you wouldn't be able to watch it at the moment. Oh, there's 9 people, 10 people. All right, people are joining. Great. Okay, so this is the second live lesson I've done. Have you pre-recorded this? Are you speaking? I'm speaking now, Grace. It is 1:01, Friday the 24th of April. So this is live. So if you want to ask a question, like you've just done, I've got my iPad at the ready as well. Oh lol. I've got my iPad at the ready as well. So I can answer your questions. I need to watch this video like you are now. So there you go. I'm on there now. Okay. So I can see. So if I just type in here, hi Grace. See if you get it. Obviously, I'm not going to do this all the time, by the way, all right? So just need to turn the sound off on my iPad. This is a disaster already. Thanks, Grace. Only joking. Hi, Grace. Right, great. Okay, so hopefully you'll like the way this works, okay? So I've got this big whiteboard now that I'm going to use rather than the little one that I was using. Where's the other one? So that's the one I have been using, so you can see the difference in size. This one's much bigger, and I've even splashed out on some really posh pens as well. Can you watch this back? Yeah, of course, because Jamie, this is going to go on YouTube, so you can watch it whenever you want. Okay. The only thing about the live, because we're live now, you can ask questions if I do something that you're not sure about, okay? Now, the only issue with that is, and one of the students in one of the classes said this, I think if you haven't got a YouTube account, you can't comment, okay? I think that's how it works. But it's really easy to make a YouTube account. My daughter, who's still primary school, we've created a sort of child's YouTube account for her. So that, because her primary teacher's teaching her like this on YouTube Live, and that's kind of where I got the idea from. So I just thought we might as well do it this way. Okay, right, I'm rambling on, and obviously if students are watching this who aren't my students, they're going to be thinking, what the hell is he going on about? So I'm going to cut all this chat out, okay? And we'll get on with the questions, okay? So there was 1, 2, 3, 4, 5, 6, 7 questions on alcohols, and when I set the questions I was trying to cover the entire topic, okay? Now these are just my questions, I've just made these up. Obviously they're kind of based around exam questions that I've seen in the past, but They're not exam questions, okay? They're my questions, okay? But hopefully it'll give you an idea as to, you know, how you answer certain questions, okay? Right. So let's get started with question 1. So question 1 said there are 4 isomers of C4H10O that are alcohols. We had to draw them, skeletal formula, name them and classify them. Okay, so C4H10O. Okay, but they have to be alcohols. So therefore, they must contain that hydroxyl group, otherwise they're not alcohols. Okay, so the obvious one to do is to go 1, 2, 3, 4, and then stick the OH group on carbon number 1. So that's obviously butane 1-ol. Okay, and the OH carbon has got 1 carbon directly attached to that, so that's primary. Okay, next one, if we just think 1, 2, 3, 4, let's put the OH group on carbon number 2 now. Okay, so this is obviously butane 2-ol, and again, OH carbon, 1, 2 carbons directly attached, so that's secondary. The next one, we're going to go 1, 2, 3, and we're going to put a methyl and an OH group on there. So this is, the longest continuous chain is 3, so it's prop. It's propane 2-ol, because we've got the OH group on carbon number 2, but we've also got a methyl group on carbon number 2, so this is 2 methyl propan 2-ol. And again, focus on the OH carbon, 1, 2, 3 carbons directly attached, so this is tertiary. So remember there's 4 of these, so the 4th one is actually another primary alcohol. So we're going to go 1, 2, 3 OH there, but we've got a carbon still to put in. If we put that in there, we've got 2 methyl propan 1, 2, 3, sorry, 1-ol, not 2-ol, 1-ol. Okay, OH carbon has got 1 carbon group directly attached, so that's primary. Okay, so that was question number 1. So just for the purpose of the fact that this is the first video like this I've done with my students. Oh, there's 20 in now, brilliant, there's only 8 left. Can you see the board okay? So I'm just waiting for somebody to go, yeah. Can you see the board okay? Thank you. Ale, ale, ale. Thanks, Georgina. Thank you, thank you. All right, they're flying in now. Can you hear me okay? I don't want to shout. So second question is about, can you hear me okay? Sorry again if you're watching this. Great, thanks Saula. I'm assuming that's for Adam's, right? Yeah man, ale, ale, ale. I like that name, ale, ale, ale. Okay, good. Right, question number 2. Question number 2, just get this up on my iPad. Show using a diagram how hydrogen bonding exists between molecules of propane 1-ol and how will this affect its boiling point. Okay, so for the diagram I'm going to use displayed formula. I think that's the best type of formula to use for this type of question. So propane 1-ol, and I'm sure everyone's going to get this right, but I like to focus on the key things that students often forget about. So propane 1-ol, 1, 2, 3, OH. Okay, we need to draw another one. Actually, that OH group, strictly speaking, it's non-linear, so I'm just going to put a little kink on that bond there. Okay, let's do another one just directly underneath. Okay. Right, okay. So show using a diagram how hydrogen bond exists between molecules of propane 2-ol. Okay, so the hydrogen bond exists between the OH groups. So what are the key things we have to remember to put on? We need to show the dipole across the bond, delta minus on the oxygen because it's the more electronegative atom of the two, delta plus on there. So let's put that one on as well. Delta minus, delta plus. Now technically we only need to do this for one of the groups, but I'm going to do them for both. You then need to show the lone pair on the electronegative atom. So we'll do the same on here. And then the hydrogen bond has to go from a hydrogen on one alcohol molecule, so that one there will go from that one there, but it's got to go to a lone pair. So the hydrogen bond would be drawn like that. Okay? So dipole, lone pairs, hydrogen bond must go from a lone pair on the electronegative atom to the delta plus hydrogen, not one of these hydrogens here. Okay? So how's that going to affect the boiling point? It's going to make it higher than expected. Okay? So the boiling point, I'll just put BPT, is higher than expected. Okay? And remember, you've also got in between this part of the molecule, you've got these relatively weak induced dipole forces. So I'm just abbreviating that there. So we've got weak induced dipole forces here. We've got stronger hydrogen bonds here. And because of that, stronger hydrogen bond, more energy has to be put in to separate the molecules. Remember, we're not breaking bonds. We're separating the molecules from each other. That's all we're doing when we boil things. Okay? So that would be what would be expected for question number 2. Okay? Number 3. Propane 1,2,3 triol is more soluble than propane 1-ol. So that's propane 1-ol. You may wish to include a diagram in your answer to explain why. Okay. So if I leave the top propane 1-ol, excuse me, on the board. So this is question 3 now. So we're going to draw a water molecule now. So imagine we put propane 1-ol in water. So let's put one water molecule in, just explain the dissolving bit. So we'll put the lone pairs there and there. So delta minus on the oxygen, delta plus on the hydrogen. There's your hydrogen bond there. So when this dissolves, the energy that's released when the hydrogen bonds form, if that's enough to break the forces holding the molecules together, it'll dissolve the molecule. Okay, so that's how propane 1-ol would dissolve. If I just quickly draw up 1, 2, 3, I'll just do skeletal just for speed. This is propane 1, 2, 3 triol. That's going to be way more soluble than that because it's got 3 OH groups, 3 hydroxyl groups. So when you put that in water, that can happen there, there and there. Whereas in this one, it can only happen on the single OH group. So this one's more soluble than that one because there are more places, more hydroxyl groups where hydrogen bonds can occur with the water molecules. Okay, so that's what I would be saying for an answer to question number 3. Okay. So, number 4. So we're getting into the reactions now. Just my iPad's for right, okay. So number 4, using skeletal formula, write chemical equations for the reactions of the following alcohols with acidified potassium dichromate 6 heated under reflux. Okay, I'm really excited because I ordered these magnets yesterday and they've arrived today, and I'm going to christen them now. I'll put a photo of them on Twitter, and other chemistry teachers are getting quite jealous, which is yeah, really sad to admit, isn't it? Sorry. Right, look at, oh, I don't know if you can see that. Try again. Right, so just a reminder that that's our reflux apparatus. Just checking you can you see that diagram okay? Oh, there's only 17 people on now. I think 3 have had enough. Yeah, thanks Joe, thanks Rebecca, thank you. Thank you. Oh, Rebecca, hi. You must have got an account sorted. Hi Catherine, hi Luke, yee. Great, okay, great. Right, okay, let's use the green ones as well. Right, so the first alcohol was butanol. So we're going to write equations for the reaction with acidified potassium dichromate 6 under reflux. So butanol is 1, 2, 3, 4. Okay, so the oxidizing agent is obviously the acidified dichromate 6. So because it's under reflux, what's going to happen, the reaction takes place in here. Remember, this is orange, and it's going to go green if there's an oxidation reaction, which it will do. The products start to form, the alcohol also will start to evaporate, goes up here, but there's cold water running around the outside of the condenser, and it just drops straight back in. Okay, so the nothing leaves the top of the condenser. Okay, you don't need a top on there, nothing's going to come out because it'll always condense and drop back in. So what we've got to ask ourselves is, what kind of an alcohol is this? So it's a secondary alcohol. What do secondary alcohols get oxidized to? They get oxidized to ketones, and that's it. Okay, so the fact that it was reflux didn't really affect things. We're always going to get a ketone in this case. So we're going to get that and a water molecule. So that would be the equation for the oxidation of butanol under reflux. The next one was hexanonol. So part B was hexanonol. 1, 2, 3, 4, 5, 6. Hex, 1-ol. So the OH group's on the end carbon. O in square brackets for the oxidizing agent. Whatever you do, don't try and put Cr2O7 2- /H+ in the equation. You'll have a nightmare. You don't do that. You always just use the O in square brackets, like I've always said. Right, so primary alcohol's in there. So I've just kind of answered a bit of one of the first questions I've got to ask. Primary alcohol, it's in there. It's going to, some of that will evaporate, but some of the product will start to evaporate as well. Goes up here and drops back in. Now, initially, you're going to get an aldehyde forming because this is primary, but because it's dropped back down, it's going to get oxidized again, and it's going to go to the carboxylic acid. Okay, so we're going to take this to the carboxylic acid. 1, 2, 3, 4, 5, 6, and the carboxylic acid looks like that. And the thing to remember with this is you only get one water molecule formed. Okay, so, and we need 2 moles of oxidizing agent to balance the equation. So there's 2 oxidations taking place. You only ever get the water formed in the first oxidation, which goes to the takes it to the aldehyde. Okay, so that was B. Part C was a bit trickier now. So this one is a diol. So I'll throw this one in to see how you coped with this. Butane 1,2-diol. Okay, so what does that look like? 1, 2, 3, 4. That's the but. 1, 2. OH on 1. OH on 2. Okay, so 1, 2, 3, 4 bute, and the OH groups are on 1 and 2, so butane 1, 2 diol. We're still under reflux with this oxidizing agent. Okay, not very much like an arrow, sorry. Right, so what I've got to ask ourselves is, what kind of alcohol groups have we got in this one? There's actually 2. This is primary, because that carbon there is only bonded to 1 directly. This carbon here, or this alcohol group, sorry, is bonded to 1, 2. So this is secondary. So you've actually got 2 types of alcohol groups in this molecule, in this diol. So it's under reflux. So we've got to ask ourselves, what's going to happen to the secondary? It's going to form a ketone. And what's going to happen to this primary alcohol under reflux? It's going to go all the way to a carboxylic acid. Okay, because remember, the aldehyde would form first, but then it just drops back into the pot, into the flask. So it'll get oxidized again because the oxidizing agent's in there. So that's the product, the organic product. We're going to get water formed on this oxidation here, just like we had there. And we're also going to get water formed in the first oxidation to the aldehyde of the primary alcohol. So therefore, we're going to make 2 waters. Remember, we don't get water formed in the second oxidation of a primary alcohol. So how many oxidations have taken place? 1, but 2 here. So we're going to need 3 moles of oxidizing agent. And again, if you want to just quickly check, it balances 1, 2, 3, 4, 5 oxygens, 1, 2, 3, 4, 5. So that's fine. So that will be equation for, which question was that? Question 4. Okay, so moving, has anybody got a question they would like to ask before I move off that? Was that okay? Silence. Gone down to 15 people now. It's going well. It's fine though. You can watch it. You can watch it whenever you want, of course. Right. All good. That was fine. Thank you very much, you two, for giving that answer there. Right. Number 5. Write the overall equation for the reaction between butanol, sodium iodide, and sulfuric acid. Name the organic product and state the type of reaction taking place. So butanol, sodium iodide, and sulfuric acid. So question 5. So what we're talking about here is a substitution reaction. So that needs to be somewhere in your answer. And if you remember, when you react an alcohol, it's done under reflux, by the way. I've left that on the board because this reaction's heated under reflux. So when you reflux an alcohol with a sodium halide, so sodium iodide in this case, and sulfuric acid, you get a substitution of the OH group on the alcohol is substituted with the halogen that's in the sodium halide. Okay, so in terms of equations, remember when we did this in class, you break it down into 2 separate equations. So the first thing to happen is the sulfuric acid, which is in here with the sodium halide, so it's NaI. That's going to generate the HI, sorry. Okay, and we're also going to make NaHSO4, sodium hydrogen sulfate. Okay, so the purpose of that reaction is to generate the hydrogen halide. Remember, it's called in situ, in that place. So the HI, the hydrogen halide, is made in that flask, and then because the alcohol is in there as well, it will react with the alcohol. So the alcohol was butanol, I believe. Yeah, butanol. I'm just going to go skeletal if you don't mind for speed. So butanol plus HI going to substitute the OH for the I. So we're going to get that and a water molecule. Okay, so that's what I would write for that, give that as an answer. And I think the only thing we haven't done yet is name the organic product. So this is a halogenoalkane. It's got an iodine on carbon number 2, counting that way. So this is called 2-iodo butane, because there's 4 in the main chain, 4 carbons. 2-iodo butane. Okay, so that was question 5. Question 6. Draw the displayed or skeletal formula for all of the organic products formed from the reaction of pentanetol and concentrated sulfuric acid. Name the organic products and state the type of reaction taking place. So, question 6. I'm going to leave this on the board because this is done by reflux as well. So I might point to the diagram, I'm not sure yet. Okay. Right, so question 6. So the alcohol was, we don't have to write an equation for this, it just says draw the displayed or skeletal formula for the organic product. But I'm going to sort of draw the starting molecule, pentanetol, 1, 2, 3, 4, 5, and the OH is here. Right, okay, so what could we form if we reacted reflux that with sulfuric acid? I think it was sulfuric I mentioned. You can use phosphoric acid, yeah, concentrated sulfuric acid. So what's it going to do? It's going to eliminate, so this reaction's called elimination, so we may as well put that in now. Elimination reaction. It's going to eliminate a water molecule, so it's also known as dehydration, remember? So the rule is we've got to take an OH group out to make water, but the other rule is the hydrogen is got to come from an adjacent carbon. So there's an adjacent carbon there, there's 3 hydrogens on this carbon, just take one of them out and that's going to put a double bond where these atoms or groups have gone from. So we're going to make obviously H2O and 1, 2, 3, 4, 5, that alkene there. Remember the double bond's going to form where you've taken this stuff off. So that's pent-1-ene. And like I always say, if you're ever making an alkane in a reaction, always ask the question, can it show EZ isomerism? Could you say dehydration? Does it have to be elimination? I would go, Adam, with elimination, okay? It is a dehydration reaction, but because technically you're eliminating a small molecule out, I would go with elimination, okay? I would probably say elimination and dehydration. I'd just cover all bases if it was asked, okay? But I think elimination, if I had to choose one answer, that's what I would say. Okay, so we're asking the question, can it show EZ isomerism? So we've got to look at the carbons of the double bond. So this carbon here, what's it got on it? It's got a 1, 2, 3, it's got a propyl group and it's got a hydrogen. So they're different. So we move on to carbon number, the second one in the double bond. What's that one got on? 2 hydrogens, they're the same, can't show EZ. So EZ, not possible on that one, okay? Obviously you wouldn't need to do that in the exam, that's just got to be going on in your head as you're answering the question. Okay, let's go down here, because remember we've got 2 adjacent carbons to this OH group in the molecule. So if we took, there's 2 hydrogens on this carbon here, so if we took one of them off, we're going to put a double bond there, okay? So we're still going to make water, but we're going to make 1, 2, 3, 4, 5. We're going to put a double bond there now. Okay? So that's obviously 1, 2, 3, 4, 5. Pent-2-ene. Pent-2-ene. Remember, ask the question, can it show EZ? Well, this carbon here has got a hydrogen on, and an ethyl group, they're different. This carbon's got a hydrogen on and a methyl group, they're different. So that can show EZ. So which one have I drawn? The priority groups are on opposite sides of the double bond. So this is the E form. So that's E pent2ene. So because it can show EZ, we'll show the other one. So it could also show the Z form, which is where we've got the double bond of the groups, like it's like a ball, remember? So we just need to turn this into an ethyl group. So you could do something like that, okay? So you could also make Z pent 2ene. So that's that one. Okay. Right. Number 7. And then we're finished, which hasn't taken. What time is it? Sorry, just how many daft things on my watch? No, it doesn't matter. It's fine, it's fine. Okay. Question 7. Draw the displayed skeletal formula for the organic product formed from the reaction of 2-methyl-propan-2-ol and a mixture of sodium chloride and sulfuric acid. Okay, and they will have also been refluxed when they've been reacted. So 2-methyl-propan-2-ol, 1, 2, 3, 2-methyl-propan-2-ol. Okay, so that's our starting alcohol, and we're reacting it with the sodium chloride, was it? Yeah, sodium chloride, the mixture of NaCl / H2SO4. So remember, this combination here is going to generate HCl and NaHSO4 in the flask, and then the HCl is going to react with the alcohol, so we're going to make the chloro version of this. Okay, it hasn't asked you to name it, but we might as well name it. So what's this called? We've got a chloro and a methyl on a propane molecule. Cl, C comes before M, so it's 2-chloro, 2-methyl propane. And that was the answer to that. So that's it. So it's only taken half an hour, so that's great. Okay. So we'll still say there's 15 of you logged in. Obviously, when this goes on YouTube, and anybody can watch it, they're not going to want to hear me rambling on to my students, so I'm going to sort of cut it short in a second. But what I want from my students, and anybody can chip in with this actually, what was that like? Be honest, okay? What would make it better? And is this the way forward? Okay, is doing it this way just as good as Google Meets? Because I've noticed loads of questions have been going up. I've tried to keep an eye on the questions. I'm just having a look now. I can't see any unanswered questions. I can see lots of students who I need to say hi to, but it's going to take forever because there's so many of you there. So I hope that was useful. If anybody wants to put a quick sort of suggestion, go for it. Otherwise, I think we'll call it a day there. Okay. Right, that's it. All right, enjoy your weekend, and I'll see you. Oh, better than Google Meet. Okay, I'm dying to know why. Better because you can rewatch. Yeah, that's why. That's what I thought, Reese. Yeah, and Joe is obviously. I think that means same as the person above. I think. I don't know. I think it was better. All right. Cheers, Catherine. Same, Lucy. Nice to see is all, even if it's just your names, by the way. Brilliant. Right, okay, this is the way forward then. So, right, I'm not going to have this chat on YouTube, okay, but I'm going to be putting something in Google Classroom because I've got an idea as to the way forward, okay. Rather than run two separate lessons that I have been doing, if we could all agree on a time where we can get on to save me doing this twice, basically, is where I'm going with that. And like you've said, if you miss the lesson live, you can always watch it whenever you want, okay? And you can message me on Google Classroom if there's anything you still don't understand. So personally, I think this is the way forward, and I'm pleased you all think the same. You seem to think the same anyway. Okay, right. Well, stay safe, okay, and I will probably see you again on Monday, and we'll go through the halogenoalkanes stuff on Monday. So I'll do it with you sort of privately, if that makes sense, and then I'll shove it on YouTube and anybody can watch it. Okay? Okay then, bye! See you later.